So we have topic 2, which is about experimental technique. This topic 2, experimental technique, is divided into two parts. One is about how to check the purity of the substance, how we know or how we can identify whether a substance is pure or impure. And the second part is the separation techniques which we use for to separate different types of substances from each other. The learning objective for 2.1, that is the measurement. So you should be able to name the appropriate apparatus to measure the time, temperature, mass, volume, include burettes, pipettes, and measuring cylinder. So as we discussed this yesterday, it's a quick revision. So example, if you want to measure a time, so the apparatus we use, that is a stopwatch or a stop clock. If you want to measure a temperature, we use a thermometer, and these are the types of thermometer. You don't have to learn right now. You just have to understand the fact that to measure the temperature, we can use thermometer. To measure the mass, we use a balance, and to measure a volume, we can use a beaker, a burette, pipette, measuring cylinder, and a gas syringe. A beaker, if you want to measure a large volume, approximate large volume, we normally use beaker, but not exactly approximately. If you want to measure accurate volume to 0.1 cm cube and maximum to 50 cm cube, we use a burette. If you want to measure exactly 25 cm cube, 25.0 I can say, like to be more accurate or precise, if I want to measure 25.0 cm cube, then it will be a pipette. If you want to measure a volume not accurately but to 1 cm cube approximately, we can use this measuring cylinder. And measuring cylinder have different maximums. Normally we in the lab we have 100 cm cube measuring cylinder. And if we want to measure a gas volume, in that case we will use a gas syringe. Now some questions related to this part. The question is, which piece of apparatus can only measure a single fixed volume? When they mention 250 cm cube beaker, it means the maximum value which it can record. 50 cm cube burette means maximum value it can record. 100 cm cube measuring cylinder, maximum value which this measuring cylinder can record. 25 cm cube pipette. So the question is, which piece of apparatus can only measure a single fixed volume? Only one reading. So what could be the right answer? You can use the chat to state the answer. And I want participation from everyone. A single fixed volume. So when we check the answer, the correct answer is D. But why D is the correct answer? Because when they mention we have a 250 cm cube beaker. So on the 250 cm cube beaker, it's not like only 250 cm cube is a maximum marking on that beaker. So the maximum mass which this 250 cm cube beaker can maximum volume, sorry, not the mass, the maximum volume which this beaker can hold, that is 250 cm cube. But there will be other numbers such as 200, there will be 150, 100 and 50. So We can measure other volumes also, and the maximum we can measure 250. So it cannot be beaker. What about a burette? A burette is having marking as well. This is the tap of the burette, and burette 0 is at the top. So there is 0, the maximum is 50, and then in between numbers are there 0 0.1, 0 0.2, 3, 4, 5, 6, and so on. So we can measure maximum, we can measure 50 cm cube, and the smallest we can measure 0.1, and we can measure the value in between. Like example, if I want to measure 24.5 cm cube, I can use a burette. So we can measure different volumes, not a single fixed volume. So it cannot be a burette. A measuring cylinder, same thing. 100 cm cube measuring cylinder means maximum value which this can record is 100, but it's not like only one marking is there on the measuring cylinder. There are other markings as well, like 90 will be there, 80 will be there, 70, 60, 50, 40. So we can measure other volumes as well. But what about the pipette? When you see a pipette is having only one marking. When you check the pipette, it is having only one mark, and that is the 25 cm cube mark. There is no other marking on the pipette. So when we fill up this pipette, it we reach a point when the volume of the liquid reaches this point. It means we have 25 cm cube of liquid. Is it clear? Is it clear to everyone that why D is the right answer for this question? Which piece of apparatus is used to measure 13.1 cm cube of dilute hydrochloric acid? A, B, C, or D? Balance, burette, conical flask, and a pipette. So which piece of apparatus can measure 13.1 cm cube? A, B, C, or D? Everyone should participate so it shows your understanding of the topic. It's not an issue even your answer is wrong, so that you will learn from your mistake, and I will discuss each question. The correct answer for this question is B. But why B is the right answer? Look, a balance. What is the purpose of the balance? A balance is used to measure the mass of an object. So it cannot be balanced because we want to measure a volume. 13.7 cm cube is a volume. So it cannot be balanced. What about burette? Burette is used to measure a volume, and it is accurate to 0.1 cm cube. Like if we want to measure if to accurate to 0.1 cm cube, we can measure accurately by a burette. So this is 13.7, so it's zero point 0.1 decimal place. So which is the most accurate apparatus here? Burette. What about conical flask? The purpose of the conical flask is to swirl or shake the mixture. This is how the conical flask will look like. If we want to swirl or shake the mixture or a content, we normally use a conical flask. So conical flask is normally not used for measuring purpose. It is just to shake the content in the flask. And a pipette, why it cannot be pipette? Because it can only measure accurate volume of 25 cm cube. That's why it cannot be pipette. So B is the right answer for this. Is it clear to everyone? You can use your mic or you can use a chat if you still have a doubt. Which piece of apparatus is used to measure 25.0 cm cube aqueous sodium hydroxide? This is a conical flask, a beaker. This is called a dropper. Like if we want to add small quantity of a liquid, we use this dropper. A conical flask, no, markings are there, but normally it is used for swirling or shaking the mixture. So what could be the right answer for this question? C is the beaker and D is the pipette. 25.0 cm cube. The correct answer for this one is D. Why D is the right answer? Because this is a dropper. A dropper is just used to add drops. So that cannot be A. A conical flask normally used to swirl the mixture. So when we compare a beaker and a pipette, so pipette can accurate to 25, like it can measure a single volume which is 25.0 cm cube. And when they mention 25.0 cm cube, it means we want to measure it accurately. Otherwise, they only write 25 cm cube, but they did not write 25. They wrote 25.0. It means that 25.0 cm cube, it means we want to measure it accurately. So which apparatus can measure 25.0 accurately? That is the pipette. A beaker can measure, but that will not be accurate. It can measure 25 cm cube, but not with accuracy. So D is the right answer for this question. Another question, which piece of apparatus should be used to measure exactly 21.4 cm cube of water? If you want to measure 21.4 cm cube of water, which one is the most appropriate apparatus? The 25 cm cube beaker means the maximum value which it can measure. A, B, C or D? A beaker is not accurate to 0.1 cm cube. A beaker is not accurate apparatus. 21.4 means we want to measure it accurately. What about others? A measuring cylinder is also accurate to 1 cm cube. A beaker normally, smallest value which beaker you can have in a beaker like 10 cm cube or 100 cm cube. So it's not, beaker is not accurate. It's normally for large. If it's a 25 cm cube beaker, so still it will have smallest value 1 cm cube. The correct answer for this question is C, a burette. Why a burette? You can clearly see what we want to measure. We want to measure 21.4, and I told you that when we are using a burette is accurate to 0.1 cm cube. Maximum it can measure 50, but smallest value like 0.1, 0.2, 0.3, 0.4 and so on. So it is the most accurate apparatus in terms of volume. So 0.1 cm cube accurately can be measured by using a burette. Why not a beaker? Beaker cannot, it can measure 1 cm cube. Again, measuring cylinder 1 cm cube. A pipette can only measure 25, so it cannot be pipette. So what we are left with? We are left with C, a burette, which is 50 cm cube. When we say a 50 cm cube burette, it means the maximum value it can record is 50, but the smallest it is 0.1. So it is like 0.1, 0.2, 10.1, 13.1, 21.4. All these 0.1 decimal places can accurately be measured by a burette. So if we want to measure simply, if we want to measure a large volume, we normally use a beaker and a measuring cylinder. If we want to measure it accurately to 0.1 cm cube, we use a burette. So C is the right answer for this. Is it clear to everyone? So whenever you see a decimal place here, like 21.4, 13.2, so if any number like 0.1, 0.2, 0.3 is there, then which is the best apparatus? We always select a burette. If it is a fixed volume, like if instead of 21 it was written 25, so accurately 25.0, we can use a pipette. Now how we read a burette and how we read a measuring cylinder. For a burette reading, for a burette volume, the readings are starting from the top. Why for a burette the readings are starting from the top? The reason is that, like example, if this is a burette and there's a tap at the bottom, so 0 is written at the top, and then 0.1, 0.2, 0.3, so on. What is the reason for that? Because when you open the tap, you can identify how much liquid is removed from the burette. So that's why the burette reading numbers are like 0 will be here, then 1, 2, 3, 4, and so on till 50. And for measuring cylinder, because measuring cylinder, the opening is at the top. So for a measuring cylinder, so we'll have like 10, 20, 30, 40, and 50. 10 will be there, then 20, 30, 40, and 50. And we add a liquid, so how much liquid is added, that we can identify by reading the scale. Now the question is, which row shows the correct reading for a burette and for measuring cylinder? What is the reading on the burette and what is the reading of measuring cylinder? A, B, C, or D? Yeah, what about others? What could be the right answer when you read the scale? So the right answer for this one is B. But why B is the right answer? When you check, I told a burette is accurate 2.1. So this is 27. After 27, the first line will be 27.1, then 27.2, 27.3, 27.4, 27.5, 27.6, 27.7, and 27.8. So the volume of the liquid which is removed from, because we normally remove the liquid, so the volume of the liquid which is removed or reading of the burette, it is 27.8. So burette is 27.8. What about measuring cylinder? As you can see, between 30 and 40 there are 5 lines, so each line is representing 2. So this will be 32, 34, 36, 38, and then 40. Then this will be 42, and then the second line will be 44. So measuring cylinder reading is 44 and the burette reading is 27.8. So the correct answer is B. Is it clear to everyone? Why B is the right answer? So a burette reading is actually from top to the bottom, whereas measuring cylinder readings are from bottom to top. This question is related to acids, so we will leave this part right now. Now moving on to the second part, topic 2.2 is about the purity. This is our learning objective, the criteria of the purity. So if you want to check whether a substance is pure or impure, so what we can do, we can check the melting point, we can check the boiling point, or we can use a chromatography. If it is pure substance, it will have a sharp melting point. If it is impure substance, it will have a range of melting point. If it is a pure substance, it will have a sharp boiling point, and if it is impure, it will have a range of boiling point. Range of boiling point means it can boil at different temperature range. And normally, when a substance is impure, the melting point will decrease, the boiling point will increase. And in a chromatography, what we will have several spots, so we can identify that the substance is impure. A question related to this part. A substance L melt at -7, that's a melting point, and is a brown liquid at room temperature. Which temperature is the boiling point of pure liquid? Pure liquid. Pure liquid having a fixed or a sharp boiling point or melting point. Fixed or a sharp means only one number is there. A melting point is -7. What could be the boiling point of this? Substance L melt at -7. And it is a liquid at room temperature. Which temperature pure which temperature is the boiling point of a pure L? First thing, when they mention pure, it means it should have one number. It, because pure substances have a sharp melting and boiling point. Sharp melting and boiling point means it will boil or melt at fixed temperature. So it cannot be B or D. Why it cannot be B or D? Because B and D are the range of the temperature. That's why it's totally wrong. So B and D are totally wrong answers. What about A and C? So if there's a melting point, if the melting point is -7, so boiling point is always higher than the melting point. A boiling point cannot be lower than the melting point. So it cannot be -77 because -77 is less than the melting point. A boiling point is always higher than the melting point. So the correct answer is 59 in this example. So C is the right answer. Is it clear? As in the previous slide, I mentioned when a substance is pure, it will have a sharp melting point and a boiling point. But when a substance is impure, it will have a range of temperature. And they specify here that this substance is a pure substance. So when it's a pure substance, it should boil at a fixed temperature, and a boiling point should be higher than the melting point. So -77 is totally wrong because it is lower than the melting point. Why B is wrong? Because they mention it's a pure substance. Pure substance cannot have a range of temperature for melting and boiling point. That's why we are left with option C. as the right answer. Then we discuss the chromatography. What we do in a paper chromatography. Chromatographies are of different types. It can be a liquid chromatography, it can be a gas chromatography, it can be a paper column chromatography or paper chromatography. But you are learning only one of them, that is called a paper chromatography. So what you do in this paper chromatography, you this is called a chromatogram. The paper is called a chromatogram. Then we draw the origin with pencil. Why we do not use the ink pen here? Because otherwise that ink will dissolve and the origin will also move with the solvent. That's why whenever we draw this origin, it should always be drawn with pencil. Then we place a sample here, and after that we use a suitable solvent. Suitable solvent means a solvent which can dissolve this sample. So as the paper soak up this solvent, the solvent will rise. As the solvent rises, the spot will also rise with the solvent. So if we observe two spots, is it pure or impure? The sample. So this sample is impure because we have more than one spot, so that's why it is impure. And we can measure the RF value. What is the RF value? Distance moved by the spot from the origin to a distance moved by the solvent front. The last point where the solvent rises or move, that point is known as the solvent front. So example, if this is 3 centimeter, this was 10 centimeter. So spot A, what is the RF value? Distance moved by spot divided by distance moved by solvent front. So it will be 0.3, the RF value for the first spot. And what about the second spot? Example, the second spot rises to 6 centimeter. So spot B, the RF value for spot B, this is for A. The RF value for B, it will be 6 divided by 10. So RF value cannot be more than 1. Whenever you have a RF value, it cannot be more than 1. It is either equal to, can be equal to, but rare, but it is always less than 1. But sometime what happened, the sample which we are using here, we have a colorless sample. Such as amino acids. Amino acids are colorless liquids. They don't have a specific color. So when we draw the origin with pencil and we place a sample, because it's a colorless sample, it does not have, so we place a sample here, but we cannot see the sample, just that part is not visible or not colored. So what we do in this case, if a sample is a colorless substance, so if a sample is a colorless substance and we place here, we cannot see it. Then we use a suitable solvent which can dissolve the sample. The solvent will rise and the sample will also, the component in the sample will also rise. But again, we are not able to see any spots here. Why we are not able to see any spots? Because I mentioned that the substance is a colorless. It does not have any specific color. For that purpose, for colorless sample, then what we do, we spray the chromatogram by locating agent which makes the spots visible. So when we spray this chromatogram by a locating agent, it's a chemical. There are different type of chemical can be used for locating agent. You don't have to learn which chemicals are used for locating agent. Just remember the term that for insoluble for colorless substances, what we do, we spray the chromatogram by a locating agent. So what this locating agent will do, it will make the colorless substance visible. So when the colorless substance, when we spray with the locating agent, what the locating agent will do, it will, there will be a chemical reaction, and then we are able to see the spots. Before that, the spots were not visible, but the locating agent make these spots visible. So for colorless substances, one more step is there. Whenever we are using a colorless substance, we should use a locating agent. Without using a locating agent, we are not able to see any spots. Is it clear? The concept of a locating agent. So it's a chemical or a substance which make the spots visible for colorless substances. So this is showing a movement of the spot from one place. We don't have to use a locating agent here. Why? Because already it's a colored substance, so we can easily identify the color. And what is a mistake here? What mistake is done by the student? That student draw the origin with the pencil. So when you draw the origin with the pencil, as the solvent move, the origin is also moving. So that is not the right way of carrying out this chromatography. Now, a question related to chromatography. In a chromatography experiment shown, which label represent the solvent front? A, B, C or D? Which of the label is representing a solvent front? The last point where the solvent rises or reaches, that is known as the solvent front. Everyone should participate. So the solvent front, the label, the question is, you have to just mention a label. Look, this is a chromatogram. This is a chromatogram. This paper is called chromatogram. The line which we draw, that is called origin. Then we use a suitable solvent here. We place a sample and then we use a suitable solvent. Then what happens? The solvent will rise. As the solvent rises, it will take the sample. As the sample is soluble in the solvent, the sample will also move. The last point where the solvent rises and stop rising, after that it does not rise. So this last point where the solvent rise, that is known as the solvent front. So in the question, what you have to do, they are asking which label represents solvent front, A, B, C or D. So what A is representing the solvent front. What B is representing the spot. or component of the sample. What D is representing? D is representing origin. And what C is representing? C is representing the solvent. Is it clear? Yes, Saim Ahmed. You just have to, the question is which label represent the solvent front. So A is representing the last point where the solvent rises. As this chromatogram, absorb the solvent will start to rise. So when the solvent start to rise, the last point where the solvent stop rising, that point, that level is known as the solvent front. And these are the spots which we see rises with the solvent. The D is representing the origin and C is representing the solvent. Is it clear? To everyone? There is no extra solvent. What happened? This paper will absorb the solvent. So when this paper will absorb the solvent will rise with the on the paper, because it's like, for example, if you fill a glass with water and add a tissue, one end of a tissue you dip in the glass. So what happened? The tissue paper soak up the solvent. The solvent will rise on the tissue paper. Same thing happened when you place this chromatogram. The chromatogram will absorb the solvent, so the solvent will rise, and the level of the solvent will decrease in the beaker and it will rise in the on the chromatogram. Is it clear? So I'll share another link and continue this discussion. Uh, Questions related to chromatography.